Question 37. Sketch the graph of y equals the square root of x plus 1 minus 2 and verify that the value of the x-intercept is the same as the solution to the equation square root of x plus 1 minus 2 equal to 0. So I guess the first thing we need to do is actually do the sketch. So I always like to sketch in terms of parent functions. So my question to you is, how does the given graph differ from just the square root of x? So this graph right here is the same as the square root of x, except it shift it 1 to the left, because that's the horizontal. So that's the inside part, right? And then the negative 2 is down 2 units. So that's how that graph differs from the square root of x. So keeping that in mind, I'll just quickly do a table of values for the square root of x. And when I do square root graphs, I like to pick nice values. So, 0, the square root of 0 is 0. 1, the square root of 1 is 1. And then I kind of jump. I jump until I go to 4, because the square root of 4 is 2. So those are the values I will pick to shift. So now I'm going to do my shift, and my shift, I'm going to follow what I said. So let me just clarify that. If I'm going 1 unit to the left, right? If I'm going 1 unit to the left, x comma y, well, x is becoming 1 smaller, so that's x minus 1. And y is becoming 2 smaller, so that's y minus 2. So if I take all that into account, 0 is becoming minus 1, whereas 0 for the y is becoming minus 2. 1 is becoming 0, and positive 1 over here is becoming minus 1. And the shape is, where this is a transformation, the shape isn't going to be drastically different. 4 is going to become 3, and 2 is going to become 0. So I think I got enough to graph this. So let's see. Negative 1, negative 2. So they were nice enough to give us a scale here. So we'll put that here. Whoops. Not used to this yet. Negative 1, negative 2. Can't press hard. 0, negative 1. Okay. And then 3, 0. So, right, just to make sure you know, right, the square root graph kind of goes like that. So that's the shape this is making. If I want to do another point, I certainly can. I could put in a 1, which is probably a good idea. Well, I'll get ugly decimals actually, won't I? If I put in a 1, I'll get the square root of 2 minus 2. So, and then if I put in a 4, again, I'll get ugly decimals. So we'll try to draw a smooth curve that goes through here and goes up like that. And that is the graph. All right. So the next thing that we would want to do is answer the other part of the question. So this is y equals the square root of x plus 1 minus 2. So verify. So the x-intercept is 2. So I want to verify that that x-intercept is indeed a solution. So let me see. Square root of x plus 1 minus 2. Square root of x plus 1 minus 2. So I am going to substitute in x equals 2. Sorry, my x-intercept is 3. This is another important lesson. Label your axes. 1, 2, 3, 4, 5. 1, 2, 3. -1, -2. Label all your points. My goodness. And the reason I knew that is because I wasn't getting nice numbers. So I'm going to substitute in x equals 3. So 3 plus 1 minus 2 is exactly the same as the square root of 4 minus 2. The square root of 4. And of course, this was the left-hand side of that equation. And the right-hand side of that equation was simply 0. So we have indeed verified that x equals 3, not 2, is the solution to the equation, and as well it is the x-intercept of the graph.